Okay, so let's get started. We're going to be taking a look at understanding our engine charge temperature calculations and how it plays an important role in our engine load calculation, which is going to be our air mass determination for the Motec M1 programming. This is really important that we understand the influencing from the inlet air temp sensor reading as well as our coolant temp sensor reading, because these both play a role in our engine charge temp calculation. This value is going to be calculated. So if we have an incorrect engine charge temperature value, that will mean that our engine load here will be incorrect. And as a result, our air and fuel model will be calibrated improperly. And we definitely want to make sure we're accounting for all of our variables. Now, the one thing that we have to worry about when we're talking about a speed density volumetric efficiency based system where we run an inlet manifold pressure sensor and we run an inlet air temp sensor for the temperature reading to go into calculating our charge temperature, is if the inlet air temp reading is actually going to get heat soaked. If we have the temperature sensor located in our intake manifold, we're going to find that the sensor can easily absorb some of the heat soaking effect that comes through the intake manifold. And that's going to be a problem because the inlet air temperature value that we find right here, this is going to be a calculated value. It's going to go through some filtering. And what we find is if we have a skewed inlet air temp reading, our engine charge temperature is inaccurately calibrated. And we find that we have then an incorrect value calculated for engine load. So we need to understand how to deal with a heat-soaked intake air temp sensor reading. This is going to be a little bit more complex. I'm going to try to break this down and make this topic that's a little bit more advanced make sense, and how to deal with the variable of a heat-soaked inlet air temp sensor reading. Now, the best option if we're talking about a force induction vehicle, so supercharged, turbocharged, you have a front mount intercooler, the best location for an inlet air temp sensor is going to be on the cold side intercooler end tank, or mounting it on the charge pipe that comes right off of the intercooler. This way, you're representing the air temperature as it's coming essentially into the engine, but keeping the temp sensor reading out of the heat-soaked engine bay when you have the hood closed. This will ensure that you have a lot more accurate reading, and we really don't need to dig into a lot of the tables and a lot of the calibration that we're going to talk about in this training module. So by simply just moving the air temp sensor to a better location, you'll find that you don't have to go through all this extra work to try to offset a heat-soaked air temp sensor reading. Now, if you're naturally aspirated and you have, let's say, a cold air style intake, try to get that air temp sensor into a location somewhere on the intake that's outside of the engine bay or as far outside of the engine bay as you can, so that way the air temp sensor, again, is not getting the heat soak effect. Let's jump in here and talk about what we have going on, and we're going to break down using an Excel spreadsheet calculator how the engine charge temperature is actually calculated, and going through all the various parameters and tables that we have to program, so this makes a lot more sense. Okay, so I'm going to move from my fuel tuning page here, and we're going to go into our setup page, and we're going to go across here all the way under charge cooling. This is where we program and work with our charge cooling gain. We talked about that in our last training module. Now, the engine charge cooling gain represents the cooling effect from the fuel as we're spraying it into our intake ports. This is very important, and it has to be calibrated really before we dig into doing any of our calibration and setup in here. So that's why in that last training module, I went in here to manifold temperature mode, made sure that was disabled, zeroed out all of my time constants, and essentially just went in and dialed in my cooling gain. Now, what we're going to do here is try to make sense of what's going on within this calibrate window. How do we actually end up with our engine charge temperature value here? We know that the charge cooling gain affects this value, but so does the engine coolant temperature and our inlet air temp sensor reading here. What we're going to find is that we have a couple of variables that we need to account for. We have our port temperature. There's an estimate value. The estimate value typically matches our engine coolant temperature. This is trying to determine what the temperature on our intake port, on our inlet port coming into the engine, what that temperature is going to be, because that's going to essentially affect the calculations for our charge temperature, what actually gets into the combustion chamber. Now, the port estimate matches our coolant temperature, because we have cooling jackets in the cylinder head, and whatever the coolant temp's at is typically what we find the cylinder head and the inlet port then is going to be at. So that's why the port temperature estimate here matches the engine coolant temperature. Now there's a delta value, and this is looking at the difference between our coolant temp sensor reading and our calculated intake air temp sensor reading. So this is going to be the difference between the two. Obviously we have our charge cooling gains in here. We've discussed that. We understand what those represent and how to calibrate them. We do have these time constants. There's a time constant for engine charge temperature right here, and then a port time constant here as well. We'll talk about the effects of these and why we want to place some values in here that make sense, and I'll give you some good starting values. Now down below, we're going to find we have our inlet air temperature. Now this value is not necessarily going to be what comes from the actual raw sensor reading. So the sensor itself could be reading at something like 20 Celsius or 35 Celsius, but the value that we actually find placed right here depends on, or the value that's calculated right here, I should say, depends on how we're accounting for the manifold temperature, which we can find down here below. So looking here at our inlet air temperature, this is a calculated value. There's a sensor trim table here. I zero this out. I typically don't use it. This allows you to apply a quick offset to your temperature sensor reading. Again, not very useful. We have a correction factor here that's applied to the temp sensor reading. This correction factor here is calculated based on knowing the manifold temperature and how we essentially allow corrections to happen in here. So this will make a little bit more sense as we're going through here. There's a delta value that's calculated. There's a factor, which is how much we're allowing a correction factor to be applied to our air temp sensor calculated reading. And that's all coming from our manifold temperature.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.